The natural greenhouse effect is necessary for life on Earth. Without it, it would be freezing cold and our planet would be a snowball travelling through the universe. But how does mankind influence the greenhouse effect? How and when was it proven? Does man-made anthropogenic climate change exist? Well, here are some arguments that will also help you in discussions with friends.
We have known for quite some time that mankind can influence the climate. The Swedish Nobel laureate Svante Arrhenius had already written a paper entitled "On the Influence of Carbonic Acid in the Air upon the Temperature of the Ground" in 1896. At that time, one used the term carbonic acid for carbon dioxide. And Svante Arrhenius had already done calculations. He showed, for example, that the Earth's global average temperature would rise by about 5 degrees if the CO2 content in the air were to be doubled. The temperature increase due to doubling the CO2 concentration is called climate sensitivity. Today, researchers estimate the level of climate sensitivity at 1.5 to 4.5 degrees Celsius. Arrhenius had calculated almost the correct value more than 100 years ago. In a remarkable interview with the New York Times in 1957, the geochemist Roger Revelle had already indicated that we are engaging in a gigantic experiment with our planet. What did he mean by that? On the one hand, he of course knew what Svante Arrhenius had calculated, that global warming is possible. On the other hand, back in the 1950s, there were fellow researchers who even denied that CO2 levels in the air would increase at all, because natural things like the ocean or vegetation would absorb the CO2. In 1958, Roger Revelle installed a monitoring station on the volcano Mauna Loa and could prove, after a couple of years, that his assumption was correct. The natural things are just not enough to keep the CO2 content in the air stable. Due to these measurements, we now know that the CO2 content in the atmosphere is rising very rapidly. It is important to note the following about CO2 sinks. Today, our knowledge of the carbon budget is fairly accurate. Of the CO2 we emit, half remains in the air, which leads to the increase in the CO2 concentration. About 1/4 goes into the sea, and the remaining 1/4 is absorbed by vegetation, that is plants. The CO2 in the air changes the atmosphere radiation balance. The greenhouse effect is enhanced as a result of more CO2 in the air, which inevitably leads to an increase in the Earth's temperature. Today we can somehow corroborate Svante Arrhenius. Arrhenius had predicted that if the CO2 content in the air increases, then the Earth's temperature must also increase. We see that this has actually happened. Since 1900, the Earth's temperature has increased by approximately 1 degree Celsius. The following correlation becomes apparent. The animation shows the Earth's temperature evolution since 1880. The temperature increase is highly variable, both in time and space. On the one hand, this means that there are highs and lows in the temperature evolution. On the other hand, it also means that there are regions that warm more than others. Thus, we see that the Arctic, that is the northern polar region, warms more than all other regions on the globe. Meanwhile, in the animation we can actually see that there is warming almost everywhere. The color indicating the extent of the warming has now reached yellow or orange in most regions of the planet. This means we can measure significant warming almost everywhere. Global warming has consequences. For example, the ice on Earth melts, and when land ice thaws, the meltwater ends up in the sea at some point. The sea level must rise consequently. This sea level rise amounts to about 20 centimeters, again since 1900. Sea level rise is not only due to melting ice, but also due to the sea temperature increase, because all bodies expand with warming. The oceans are also warming, and that's why they expand. About half of the sea level rise of 20 centimeters is due to this thermal expansion. The other half is due to the melting ice. However, the melting ice has dominated the past few years as opposed to thermal expansion. As we have already seen in the case of temperature, sea level rise varies regionally. In the past few decades, we observed that the sea level has risen the most in the tropical West Pacific, about 3 times faster than the global average. These regional changes in sea level are related to wind force changes in ocean circulation, just like changes in winds are driven by changes in atmospheric pressure. However, there is another problem that we call the other climate issue: ocean acidification. We have seen that the oceans absorb roughly 1/4 of the CO2 emitted by human activities. This inevitably leads to ocean acidification, which negatively impacts marine ecosystems, especially calcifying organisms such corals, snails, crabs or mussels.